Let's get started. Today we're going to review systems of equations. So what I wanted to start with is just try to jog your memories on how to solve two equation things, probably by stacking them on top of each other. If you remembered that, that's awesome. If not, we're doing that right now. So let me start off with just some terminology. Often I begin my lessons just by I want to make sure we're using the right vocabulary. So most of your lives, please. Most of your lives, when you guys do algebra, you usually do what we would call single variable equations, which I think makes intuitive sense, right? There's just one letter, x, and you solve for x. Sometimes it's not the letter x, it's r or p or m, right? But at the end of the day, if there's only one letter, you can solve for that one letter. Okay. That's not the only type of equations we can solve. I don't know that you use this terminology, but hopefully it makes sense. A multivariable equation has more than one variable. We actually do multivariable equations anytime we do sciences. If I give you guys the equation from, say, physics, v equals d over t, this is now a multivariable equation, where there is a distance, a time, and a velocity that all you could solve for. Does that make sense? Rarely in math, so far, have we actually dealt with more than one letter. Usually it's in the sciences we do this, but it's an important skill to have. So today we're going to work with how to solve for things where there's x's and y's, or d's and t's. It could be smiley faces and stars. It really doesn't matter, but we need to have a system for being able to solve it. What if there's more than one variable? What if it's not just x? The basic rule is, for every variable that you're trying to solve for, you have to have one equation for each one. So if you have two letters you want to solve for, you better have two equations. If there are three letters that you want to solve for, you would need to have three equations. That makes sense? Normally, when there's only one letter that we're solving for, I only ever give you one equation, which is why that's all we've usually ever done, right? I give you one equal sign, one equation, you solve that one. So today, what's going to be different as you look over some of the examples is there's always two equations. Why are there two equations? Because there's two letters to solve for. So far, so good? Yep. So let's go to the next slide. That's actually what I just mentioned here. One equation for each variable. So you guys should have seen this last year in 10C. You should have. Okay? If not, that's what today is for. I want to show you the two main ways of trying to solve what's called a system of equations. The reason we call it a system of equations is because now there's more than one equation. That's the term system. So I believe these two equations, I now have a slide where I'm going to show you how to do those two equations using something called substitution. And on a later slide, I'm going to show you how to do something called elimination. So in case you're wondering why I'm kind of skipping around here, this example we're going to do right here, I have a spot for that on future slides. That makes sense? So here are the two main ways we're going to try to solve them. One is known as substitution. At its core, what you're trying to do is get one of the letters by itself, and then you try to find a way to substitute that piece inside the other equation. It's almost like you're putting something inside something else. You guys know, you guys ever heard of or seen like Russian nesting dolls? You know what those are? Or like there's a doll inside a doll and a smaller one inside of that and a smaller one inside of that. Yeah. I think of that when it comes to this, where one of the equations is like a doll, but inside it, we're going to try to find a way to take the other equation and put it inside as though it's the smaller of the dolls. I don't know if that analogy makes sense. That's one method. The other one, called elimination, is where you either add or subtract. It doesn't actually matter which one you pick, but you line up equations, you add or subtract, and you try to eliminate a variable. So let's just do an example. Let's try to solve this by substituting. First thing for substituting, we would like to get one of our letters all by itself. Doesn't matter whether it's x by itself or y by itself, but let's get one letter by itself. Okay, cool. X is by itself. If you like the Russian nesting doll example, what we're going to do is we're going to make this right here be the smaller of the dolls, like the little things that go inside each other. And we're going to take it and we're going to put it inside the bigger of the two equations. Where specifically should it go, though? Anywhere there's an x. So it needs to go inside that section, and it needs to go inside here. So here's how this would look. we still have a 3. But rather than writing x, we're going to write what x is equivalent to, which is 3 minus 2y. Am I grabbing the door and closing that just to put it in noise? Well, I still have to add y. Still need my equal sign. Still need my 4. Oh look, there's an x there. But x is equal to something. It's that smaller doll that's going to go inside. So what's inside? Well, 3 minus 2y. Don't write x, write 3 minus 2y. The other reason I like the doll example, if you're visual, if this makes sense to you, that's awesome. If it doesn't, I'm sorry. But is that you can see how with the brackets there, you can kind of really see how it's inside. Does that make sense? Like you're actually putting it inside something else. I still need that minus 7 too, right? So in a way, I still have 3, but now there's just something inside. It's the, rather than x, it's this stuff. I still have the plus y. I still have the 4, but rather than writing x, I've used a bracket and I've put the other doll inside, and minus 7. Is this still multivariable? Look at my equation. No, there's only y's left, which is good because one equation, one variable I can solve. So let's use the methods I've shown you over the last couple of weeks for solving. I like the rope analogy. There are some brackets here. Let's untie the rope. So 3 times 3 is 9. 3 times minus 2y minus 6y. So just add another y. Put those guys together for 12 minus 8y and minus 7. If you like my rope analogy, it's now untangled. Now we just need to pick the right strategy for how to tie the proper knot. Do we need the quadratic formula? Why not? It's not quadratic. Do you see any squared terms? Okay. So the proper method for retying this rope properly, put all of your variables on one side, put all of your numbers on the other side, solve as though this was grade, I don't know, 8, 9, whenever you learned algebra for the first time. So let's put all of the y's on, let's put the y's on the set. So if I add 8y to both sides, you would have 2y on the set. Let's put all of our number, oh wait, no. Oh, I missed one, didn't I? 3y. Oops. Okay, so that accounts for these guys here, and those ones. Then I should subtract 9 from both sides, put it on the other side. Should I do math that's screwing up today? Minus 4. So that's a 16, and divided by 3. I have an answer. Y is minus 4 over 3. We're not done though. With the system of equations, we have to find what both the x and the y are. Or in physics, we need to know what both the distance and the time happen to be. If we have an unknown variable, we need to find all of the unknowns. So, although we know what y is equal to, we don't actually know what x is equal to yet. But here's where this is kind of cool. When I have an equation right up here that tells me what x is equal to, x is equal to 3 times whatever minus 2 of y is. So if I'll just use a new color here. I'll go back up here. X was supposed to be equal to 3 minus 2 times whatever y was. But we know what y is now, right? It's minus 4 over 3. Fractions. Did I say that fractions are one of the F words in math? Which I told you guys before. I think there's 2 F words in math. Factoring and fractions.
And fun.
Okay. Do you guys remember how to multiply fractions? Pretend it's like 2 over 1. And go top times top, bottom times bottom. So in a way, it's 2 times minus 4. So that's negative 8. Although maybe I should do this. It's negative 2 times negative 4. So I'll make it positive 8. And then the 1 on the bottom times is by the 3 to give us 3. Should I do that again? Fractions are not always easy for people. Let's back up here. So we plugged in the 4 over 3. I'm just going to focus just on this part right here. So what I've got is 3, and then I'm doing negative 2 over 1 times by negative 4 over 3. Negative 2 times negative 4 is 8 times this top by that top. It's almost like it's 2 over 1, right? That's where the bottom of the fraction is. So 1 times 3 is 3. So I need 3. Double negative means plus. 3 plus 8 over 3. Shoot, I still have fractions. F. You guys remember how to add fractions? We need common denominators. Whoever said that, good job. So the denominator of this 3 that's been sitting up front the whole time is it's over 1. Okay, so maybe this looks familiar. You times this by 3 and by 3 and make it 9 over 3. I just heard someone say it. That would be your answer. So to catch you up in case that missed there, this 3 over 1 and this 8 over 3, they don't have common denominators. To do so, I times both of this by 3, because then it's 9 over 3. 9 over 3 is 3, it's just it's not simplified. Then the rule is the bottom of the fractions better be the same. It is. So we just add the tops. 8 and 9 is 17. So here's our final answer. Y is negative 4 over 3, and x was 17 over 3. Be forewarned, you will get fractions. Sometimes you get nice whole numbers, but we are going to work with fractions though too. Minus the fact that there were some fractions in there. Did that sound familiar? You have done something like that before? That's actually one of 2 methods. There is another method known as elimination. And so I'm going to try to show you how to do the elimination method as well. It really depends on the context of the question. Like I can't just say always do one or always do the other, because it depends on what sort of variables you have. Usually one is easier than the other one. So, in order to do elimination, this is what I try to teach, and maybe Quan did something different, but I try to teach that we always want to have things line up very nicely in rows. So I want to have a row of x's go next to a row of y's, go next to a row of like numbered. And if I try to line this equation up as it is right now, if I try to take this equation and just write it next to it like this, do you see how like nothing's really lined up all that well? I'm going to try to rearrange it so things line up a bit nicer. The biggest issue I have right now is that this 2y is currently on that side, but the other y's of the other equation are on the wrong side. So I'm going to do a little tweak and I'm going to add 2y over to this side. And now it's almost to the point where I can start to line things up in columns. This is how I show this. I'm going to find a column first of everything that's an x on this side. So for the first top equation, 3x. For the bottom equation, just fill x. Okay, then I'll pick the next variable, y's. So the top equation has 1y. The bottom equation has 2's. Really, I'm just flipping the order of these, just so they line up nice and neatly. Makes sense? Okay, this side has a 4x. How many x's are down here on this side? I can go with that though. There's 0 x's on that side over there. I know that seems kind of weird, and maybe this isn't exactly what Quan showed you. Bear with me. That's a 0, by the way. And then I'll line up my numbers. So, I was using red. I have a -7 in the first equation, and the bottom equation has a 3. You see, I'm trying to get everything into a nice column, so that when it's stacked on top of each other, I have x's in one column, I have y's in another column, x's in another column, numbers in another column. That's all I was doing, was just rearranging just purely to get this to fit. The next thing I do is I want to try to make it so that one of my letters has the same number top and bottom. And actually right now none of them actually did. Because here there's 3 and 1, that's not actually the same number. Here there's 1 and 2, that's not the same number. Here there's 4 and 0, still not the same number. And here there's 7 and 3, not the same number. So what I'm going to try to do is I'm going to try to times an entire equation to make it so that the numbers, that the amount of them are the same. And here's how I think this will be easiest to do. I'm going to make that a 2. Because now look, 2 and 2, I have the exact same thing. And if you know how elimination works, you may be able to predict how that's going to be helpful later. But can I just sort of times this by 2? That's not fair, right? I need to take the entire equation and double the whole thing. So this is now a 6. This is now an 8. And this is now a 14. This is how I show it. I'm now going to draw a line underneath it, and I'm going to subtract. And maybe you'll see why this was useful. Can I take 6 x's and minus 1 more x? Sure, I would have 5 x's. This is the linchpin of the whole problem. This is why it's called elimination. What happens when I take 2y and subtract 2y? 0 y's. We have now eliminated one of our variables, and there's no y's left. So I'm not even going to bother writing it. What if I take 8x and I subtract 0x? That's still silly x. And what if I take minus 14 and I subtract 3? Negative 17? Is that right? Yeah. Well, now I have single variable, because I have 5x equals 8x minus 17. Alright, so why don't I maybe minus 8x from both sides? That'll give me minus 3 equals minus 17. Divided by minus 3, divided by minus 3, x equals, there's 2 negatives, right? 17 over 3. Okay. Isn't that what we just said it was the last time around? Now, I don't know which one necessarily is easier, because they both have strengths and weaknesses, pros and cons, but that's not too bad. Usually what people do at that point then is they take the x value, they plug it right back into the equation up here, and they solve for what y is. But I'm actually going to do a second elimination example just to show you that you could have eliminated to solve for y instead. Let me re-go over what I did though, just to make sure the steps are clear. First, I wrote the 2 equations on top of each other, and I rearranged it to make sure that everything lined up in the same column. Otherwise, it just doesn't really work that well. Secondly, I times one of the equations to make sure that something would eliminate. Here I times it so that these y's would eliminate. So I just doubled the whole top equation. Then I subtracted. It gave me a new equation that does no longer has y's, hence the term elimination. And I just solved the leftovers. What if I didn't eliminate y? What if I eliminated x? Is that doable? Let's try it. So you get more examples. Let me just rewrite this one again here. So I'll write like the x. Actually, you know what? Let's try something even more different. You guys see how there's 2 x's on this side over here? What if, watch this, what if I were minus 4x from both sides? What would I have? I would have negative x plus 4 plus y equals minus 7. I'm now going to take this equation right here, and I'm going to try to bring it and stack it next to this one as well. So if I write it like this, x equals minus 2y, x equals 3 minus 2y. You see how like the y's, maybe I should bring that 2y over to this side right here, so I can have everything stacked nice and neatly. So I kind of played a few tricks there. Just do that one more time. So in the first equation, I said, look, there's 2 x's sitting on opposite sides of the equation. Let's bring that 4x to the other side. So it gives me negative x plus y equals minus 7. I said, well, I want this equation to stack with it. So I'll put the x right here and the equal sign. The 3 can go underneath the 7. There's this minus 2y sitting right there. why don't I just bring the minus 2y and put it on the other side, make it plus 2y. Now is everything in a nice kind of column? Yeah, life is good, okay. This time around though, I'm not gonna subtract, I'm gonna add. Because I actually am in a situation where something can eliminate. You see how you have negative x and positive x? Subtracting won't make them go away, but if I add them, it will. Because negative and positive x will just be gone, right? Y plus 2 more y's gives you 3y. Minus 7 plus 3 gives you minus 4. Divide by 3, divide by 3. Y was minus 4 over 3. Which is what it was over here too. Should I go back in there? So let me try that one more time here. I'll just back up a few steps and do it one more. Whoa. Where am I? Undo. There we go. So if you can get to the point right here, where I had these two equations on top of each other, at this point here, I want to make one more tweak. I like that the x's are in the same column. I like that the numbers are in the same column, but this 2y was kind of not in a useful spot. So I added 2y to the other side. Now look, everything's all kind of lined up just perfect, right? If I add them together, negative and positive of x is just completely gone. 1y and 2y is 3y's. Negative 7 and 3 is negative 4. And all I gotta do is just divide by 3 to get what y is. So that's something you should have learned last year. Now, if you're not great at that, that's actually kind of the point behind this year. Only we're gonna throw one more twist into this. All of those were equations that had a degree of 1. Meaning that the exponent on the x's or the y's, there wasn't any exponent really, right? The exponent was 1. What have we been working with recently? Quadratics, which have a degree of 2. So we're going to take two skills that we've learned. Last year, plus for like 20 minutes today, you learned about systems of equations, elimination and substitution. This year, I've been showing you about how to deal with quadratic equations. We're going to meld the two of them together. It's like peanut butter and chocolate going together. It's going to be super awesome. So it probably won't be because it's two very challenging things. So that's my next slide here. We're going to try solving quadratic equations with multiple ones. Similar to the quadratic formula then, we could have one answer. We could have multiple answers, like 2 answers. And it is possible for the answer to be, there is no answer. Is excited?
Not really.
No. Alright, so let's try it. As I've got these two examples here, or these two equations here, start at the beginning again. Why do I have two equations? Well, I have two equations because there's two letters I need to solve for. Right? I'm going to solve for x and for y. What I need to figure out how to do is either do a substitution or an elimination, one of the two. Doesn't matter which one. You should get the same answer either way. So I have a suggestion. I see that right here there is a y. Just a single y by itself. And although this y right here is on the wrong side, can you guys kind of see that if I were to bring that y to the other side, I would then have a single y on that side of the first equation, and a single y on the second side of the second equation. That would be perfect for elimination. I just need to set it up properly by stacking them. So I got to do a little bit of work first, but eventually I'm going to stack these two equations on top of each other. I think I've already done the first set here. I've got 13x plus 2 equals y. That's not bad. The second equation needs a little bit of work though. How do I do it with bracket? Boil it out, yeah. Does it out. So I should have 2x squared plus 8x equals y plus 1. I think I'm ready to stack them on top of each other. I'm going to start lining things up in columns. Does this equation have any x squareds though? Yeah, that'll help. I have no x squareds. Well, below the 0x squareds, I'll write that I have 2x squareds in the other equation. There's the 8x. I'll write that one there. Okay, then I want a number. The number's on the wrong side, eh? Like in this equation right here, the number was on the wrong side. That's easy to fix, right? We'll just take the plus 1 and we'll just minus 1 over here. Okay. This is perfect for elimination. Because now what I'm going to do is I'm going to make sure everybody's all kind of lined up in here. Should I add or subtract these equations to make the y's disappear? Subtract, right? Because I'll work this way over. If I do y minus y, it's just straight up gone. Well, what's left though if you do y minus y? Good, 0 actually, yeah. There's going to be a 0 left. By the way, that's going to be really useful in a second. Remember how quadratic, sometimes we want them to equal 0? That's actually good. We're subtracting, right? 2 minus 1. Watch the double negative. 2 subtract minus 1 is actually 3. Because the double negative is that, right? 13 minus 8 is 5. And 0 subtract 2 is negative 2. How many answers am I going to have? I might have 2, because it's quadratic. So we now need to choose some sort of method of solving this quadratic. How about the quadratic form? That's a good idea. So, negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's start plugging in some numbers. I need to stand ready. Okay, so the b value is the one in front of x, so that's 5. So negative 5. Then we got to use 5 again. A. What's the a value in this one? Good. Don't forget the negative too. That makes a difference. And the c value is 3. All over 2 and negative 2. Okay, we got a little bit of work to do here. I'm going to simplify this because it's kind of gross right now. What's 5 squared? 25, right? Okay, I need a negative 4 times a negative 2 times a 3. A negative 4 times a negative 2. That makes it a positive number, right? Times a 3. What do you get? 24? I think it's 24. But it's positive 24, right? Because this negative and that negative combine to make it positive. And then last little bit, what is 2 times negative 2? Negative 4. Maybe you're a little bit ahead of me even. I don't know if I'm going too slow or too fast, but 24 and 25, we can add them, right? I'm just going to do this in 2 steps here. Doesn't that make it 49? Doesn't 49 though actually square root to 7? So really, here's my 2 answers. One of them is minus 5 plus 7 divided by minus 4. That's one of the answers that it would be. I'll fix that in a bit. The other answer would be minus 5 minus 7 or minus 4. So let me walk you through that again. The 25 and the 24 really makes 49. 49 can square root to 7, right? Minus 5 plus the 7. Minus 5 minus 7. So now I just need to try to figure out what these answers are. What is minus 5 plus 7? 2. Divided by minus 4, it would be 2 over 4. It would be 1/2. But it would be negative 1/2. There. There's an answer for, I think it was x, wasn't it? Minus 5 minus 7, minus 12. Minus 12 divided by minus 4, 3. Okay, apparently we have 2 answers. Because it was a quadratic, there's actually 2 answers for x. So you're going to love this. We're not done yet. What have we missed though? We have to get y. So now, I'm not actually going to solve the rest of this question all the way through. We'll just talk about how we solve this. If we have an answer for x, is this to these guys here?
Yes, please.
Take one, pass it on.
Now my picture.
No. Take each of these values for x and plug it back into one of the equations. For example, where were we here? Here is an equation. We could take our answer for x plug it in, I would say plug it in right here, and solve for y. The only difference is you have to do it twice. For every value of x you get, you're also going to have a value of y. So I'm going to skip that step because that's not necessarily the new part as much. The challenge here is, can you set up a system of equations using either substitution or elimination? And can you recognize that now we're going to have maybe 2 answers for x, and then also 2 answers for y? That's what the challenge comes in. That all make sense at all?
A little bit, yeah.
We're going to do lots of examples. Like, I still got another half hour. So let's try another one. 5x minus y equals 10, and x squared plus x minus 2y equals 0. First, we got to figure out what our plan of attack is. General rule of advice. If you can see an obvious way, I guess we're all reading the letter. If you can see an obvious way to cancel out a letter by stacking them on top of each other, go for that. I don't actually see a great way here though, because this has got 5x and that's just 1x, and this has got y and that's got 2y. So I mean, I can work with it, but maybe let's try the other method. Let's try to get one of our letters by itself. I actually see a very easy way to get one of the letters by itself. Let's get this y by itself. Yeah, why don't I add y to both sides? And minus 10. 5x minus 10 could equal y if I do a quick little bit of algebra over on this equation here. I think this is the smarter method this particular time around, because this is now where we're going to take the little Russian nesting doll and we're going to put it inside the other location. So this is the other method I'm trying this time. Take this 5x minus 10 doll and put it inside that little spot. That's called substitution. What would this new equation be then? You'd still have x squared. You'd still have x. You'd still have minus 2. But the little doll inside the big doll, rather than writing y, we're going to write this 5x minus 10. How many equations do I have? 1. How many letters do I have? Actually, just 1 now, right? All right. So back to my rope analogy. It's kind of gross. We got to foil some stuff out, but this is a quadratic. This is what we've been building towards. So we're now taking the 2 different skills and putting them together. You're now at a point where we've been here before. Let's foil this out. You still have x squared. You still have x. You'll have minus 10x. You'll have plus 20, and it'll equal 0. It's equal to 0, that's good. What else can I do? Combine your like terms, right? Minus 9x plus 20 equals 0. I could use the quadratic formula, but I think we can factor this. We need numbers that add to give the middle number of minus 9. We need numbers that times to give 20. I'm pretty sure those numbers exist. Yeah, it's like 5s and 4s. Let me write it out, though, for anyone who needs it. We need numbers that add to give minus 9, and numbers that multiply to give 20, and it's minus 5 minus 4. Do I have to break up the middle term? Not on this one. If the leading coefficient is 1 up front here, you actually don't have to. You can go right, you can use the shortcut if you know how this works. You can go right to x minus 5, x minus 4. But that only works if there's just a 1 up front. Well, hopefully we've been at this point a few times before now, right? This means that x is 5, and this means that x is 4. I have 2 possible values for x. Okay, I think I'll actually solve this one for y. Because last time I was a little bit lazy, I didn't bother solving for y, but I should find out what the y values are equal to. If I have 2 values for x, I should have 2 values for y, right? let's take this equation right here. See how this equation was 5 times x minus 10 to get y? Well, one of the answers for x was 5. 5 times 5 is 25. Minus 10, 15. The other answer would be 5 times 4. We'll make x be 4. 5 times 4 is 20, minus 10 is 10. All right. So what's going to be new for you guys is we have 4 answers. And I need you to have all 4. X is 5 or 4, and y is 15 or 10. There's actually now 4 solutions to this question. So you have to take your ability to either do substitution elimination, which on its own is a pretty challenging skill. And after you're done, you may still end up with a quadratic, which requires a quadratic method of solving. Either factoring, or if factoring isn't happening, use the quadratic formula. Why don't you guys take a quick wiggle break? Because I got lots more to do, and I want to make sure you're able to focus. So come back in. Alright, sit back down again, guys. We got lots more examples we need to cover. So hopefully a little wiggle break kind of gives you enough to get to the end of the day. I would suggest that in order to be good at this, well, yes, that of course, but most people are successful by the method they choose. Can you guys focus again? We're good? If you can look at the question and figure out whether you should do elimination or substitution and figure out which method is most efficient, I think that helps students the most. Being able to look and say, well, I have 2 choices. I can either stack them on top of each other, or I can throw one inside the other. If you can look at the equation and see which one is going to work for you, I think that helps a lot. Now, there's not one that's righter than the other one, but sometimes there's one that's more efficient. On this one here, I happen to see something that I think is very useful. There is a single y on that side of the equation, and there is a single y on that side of the equation right there. I feel like stacking them is a good choice. Now, it's not the righter choice, but I think that's very efficient. It's going to limit the number of moves I have to make, and the less work you have to do, the less likely you are to make a mistake. As you can see that some of the questions we're solving now, it's not like 2 little lines of work. It's like it's a full page worth of math, right? So if you can work on your efficiency in terms of how many steps you have to make, that limits your mistakes usually. So I would then start setting it up where I'm going to go 0x squared plus 3x plus y equals minus 9. I'm just going to write the 0 up in front of this one. And I'll stack this one right below it. 4x squared minus x plus y equals minus 9. This is perfect. I hardly had to do any work. I don't have to do a lot of rearranging. No other stuff happening. Okay. Do I add or subtract? What will eliminate the y's? Subtracting, well, yeah. So here's what I usually do. I write a big subtract sign off to the corner just so I remember that I'm subtracting. But use whatever method works for you. We have 0x squareds. We have to minus 4 of them. Minus 4 of them. I have 3x, and I'm minusing minus x. Double subtract actually means to add, right? So I got 4x. Y minus y. Reduct. I won't even bother writing anything then. Minus 9 minus minus 9. 0. Minus 9. Minus minus 9, right? The minus minus means add, right? So what you really have is minus 9, add 9. Okay, so here's where we're at. Minus 4x squared plus 4x equals 0. Okay. Now we just have to figure some method of solving this. This was the new stuff, right up here. This was trying to figure out how to do our elimination substitution. Is that last movie? Yes. Okay. So at this point here, we've got options. We need to find some way of solving a quadratic. So let me walk you through some ideas. You can use the quadratic formula. That'll work. You could factor. Anybody see anything you could factor here? Are there any things in common? A 4 and an x. Watch this. I'm gonna factor out a 4 and an x. What would I be left with? If I factor out the 4 and the x in this. The first one would be negative x. And well, I factored the entirety out of this thing here. So I have to leave something in its place, so I have to leave a plus 1. This isn't so bad. I think it's a little faster than the quadratic formula, maybe. I now need to make 4x equal 0. The only number that would make 4x equal 0 would be if x was 0. Here's another way of looking at it. If I divided both sides by 4, 0 divided by 4 is still 0. There, I've got an answer. Ta-da. That was good. Save me that whole quadratic formula work, right? What about here? If I have negative x plus 1, that has to equal 0. This is a bit of a twist though, right? We don't usually have a negative x. Let's go with it though, right? Let's subtract 1 from both sides. Negative x equals negative 1. Negative x equals negative 1. Shouldn't positive x equal positive 1? Yeah. Do you see what I mean though when I said efficiency is good? You could have tried the quadratic formula, by the way, on this. It will work, but it's going to be a lot of steps. And if you can find a way to factor, it saves you time. And that's ultimately a good thing. You could have up here probably did substitution, and it would also work. But I really strongly feel like by just stacking them on top of each other, that was a good time saver. I just have one more thing to do. I've solved for what x is equal to. Solve for what y is equal to. So 0 or 1, let's go back up here. If this x is 0, well then all of that's 0. Well then y is minus 9. That was pretty straightforward. What if this was the number 1 right here? Well, it'd be 3 times 1. That's 3. It's on the wrong side though, right? So if I minus 3 from both sides, then that's gone. Y would be minus 9, but we'd have to minus over a 3. Minus 12. Because it's minus 9, minusing 3 more. Yeah. Sometimes there's a lot of ways of solving. You could choose to eliminate or substitute. Then when you get a quadratic equation, you could factor. You could use the quadratic formula. So when it comes to solving these ones here, normally I'd like you guys to be able to mark your own work. I'll probably have to mark most of your systems of equations, just because there's so many ways you could solve it. But at the end of the day, I don't care which way you solve it. You should get the same set of answers. If you have 2 x's, you should have 2 y's. If you have 1 x, you probably should have 1 y. What if it's unsolvable for x? Actually, it's also unsolvable for y. Yeah, and that's actually one of the nicer ones to get once in a while, where when you discover that you can't solve for x, and it's like, oh good, I don't even have to bother solving for y because I can't. So I've done a few examples now. Why don't I have you guys try one? Try this next one here. Try to figure out what you think is the best way of solving. You can do elimination, you can do substitution. I'm going to start solving it after I give you a 5-minute head start. You will likely have different work than me. Okay? But at the end of the day, if you get the same answers as me when I'm done, then we're good. So take a head start here. See what you can do. See if you can solve this thing. Solve for x and y. Possibly more than 1 x and more than 1 y. Jill, that's the thing that you just did it the opposite way. Okay. You're not supposed to go early, you see that after school. Does anyone have any questions about how I solved mine? Why don't we walk through it real quick? So, regardless of where you're at, can you guys give me your ears for a second? Let me walk you through what I did. Here's my thought process. I noticed this, ooh, let's get rid of that line there. I noticed this negative y right here, and I thought this is a prime example of elimination. Because if I set them up properly, I'll just do some, you know what I mean? So, in terms of math then, I did a little foiling right here. Right there. And I did a little foiling right here. And then I noticed that I have x squareds on the left-hand side. I have a negative y on the left-hand side. But this one has the x on the left, and this one has the x on the right. So I just made a quick little shift, and I threw the x back on the other side by throwing it this way. It actually didn't matter which equation went on top or bottom, but I put this one on top and this one on the bottom, and I lined everything up real nice. Are you guys focusing? No, can you focus, please? After I got them lined up, then the next question is, do you need to add or subtract? And the way you figure that one out is by looking at what you're trying to eliminate. I'm trying to eliminate these y's right here. If you do minus y and you add another minus y, actually minus 2y, that doesn't help. But if you subtract, the double negative will actually help get rid of the y. You gotta be really careful with those double negatives, because if you screw up on them, the whole thing's shot, right? So 3 minus 6 is minus 3. Minus 1 minus 4 more is minus 5. These ones went away, and 2 minus 4 is minus 2. At this point here, I recognize this is a quadratic equation. My personal preference, I've shared this with you a lot though, I hate having a negative leading coefficient. This negative 3x squared drives me bad. So I decided to throw both of these terms on the other side. And I got to this. Now you can use the quadratic formula if you want to. But it just so happens that I could find some numbers that work. I split it into pieces, I factored, and I found some answers. I make it sound real easy. But here's the whole point of this unit here. It was all building on each other. We started off by learning how to expand, and then how to factor, and then how to solve, and then how to do the quadratic formula. And at some point, this point right here, really this is a question I've asked you before. I've asked you to solve that before. Right? And so what's going to happen as we go further and further in this unit is we're just going to go like one step further. And then as you do a bit of work, you get to a point where you're like, oh, I know how to solve a quadratic. You just choose whichever method works. I don't have a lot of time left, so I don't want to actually solve this last question. I just want to talk about what a good strategy would be. Would stacking these equations on top of each other work really well? I don't think so. I don't see it being particularly useful. But I have a different idea. Let's do that inserting a substitution piece. What if I were to take this y plus 4 and plug it in right here and right there? So stay with me. I know I've only got 5 minutes left here, but try to stay focused. We don't have tons of time to cover this. If I did that, here's what I'd have. I'd have y plus 4 squared plus 2y squared minus 11. But rather than writing x, I'd write y plus 4 minus 3y plus 31 equals 0. We've been here before. The analogy I've given is this is like a really tied up rope, right? Foil it out. It's already equal to 0. Once you're done foiling it all out, put your like terms together, either factor it, or use a quadratic formula, whichever one happens to work. One step I've been skipping, I haven't always been taking my x values and resolving for y. Because again, some of these questions are getting so long and convoluted that, I mean, it takes you 5-10 minutes to solve one, doesn't it? So, on an actual test or assessment, you should actually go all the way through and do all of the steps here. But sometimes we'll shorten it a little bit to try to get the highlights down. Was that the last example? Okay. Do you guys have any questions? Okay, give me 1 more minute, then you guys can go when I'm done talking, okay? Let me do my talking first. Just quick summary. So, that's a challenging lesson. Don't get me wrong. Like that one takes 2 quite big pieces of quadratics and systems of equations and puts them together. My goal now is to take Thursday and take Friday and give you some more work time. On Monday, we're going to do a quiz. Okay. This will be on the quiz. It's not going to be the only thing on the quiz, but it's something I will assess you on. Okay. What I would really recommend, to the best of your ability, if you can finish the assignment by tomorrow, I think that would help you the most. Because then I can go over it with you on Friday and help you make any corrections you need before the weekend. Does that make sense? It'd be best to do that before the weekend, because truthfully, if we do that, that's your studying. Yes, stop moving. Please, just stop. As soon as I'm done talking, I'm gonna let you go. Okay. That'd be the advice I'd give you. I know that's not always possible, but I mean, in a way, you've got 45 minutes of flex time, you have an hour and a half of class time. It's realistic if you work hard. Does that make sense? So if you can, try to finish it. Either way though, the assignment is due at the end of Friday. Okay. So if you want it to not be considered late, finish it by Friday and marked as well. Okay. So, sound good? Okay, see you guys later.